When operating a Resid FCC unit, refiners can face multiple issues and decisions, which may include equipment fouling, having to monitor the quality of feedstock, etc. In this seminar, we will share the experiences of a South Korean refiner who experienced shutdowns of Resid FCC unit equipment and several instances of component leakage. The refiner attempted repairs of the units after undergoing a 50% charge down. The refiner reported results including lessons learned. The refiner experienced catalyst cooler tube leakage believed to be caused by improper insertion of the inner tube in the outer tube and oxidation and thermal shock of the outer tube cap caused by exposure to temperatures of 720 degrees Celsius. The refiner performed a balloon plug test to detect the affected tubes, which were then plugged. The lesson learned was that tube insertion should be checked through a side nozzle or via a different method. The refiner also experienced catalyst cooler aeration pipe failure believed to be caused by the formation of a fatigue crack caused by the change in thickness from the elbow to the straight pipe. Corrective actions included replacing the cooler and checking the pipe welds for cracks using dye penetration and radiographic tests, and replacing the thicker elbow with the same sized piping used for the straight piece. Lessons learned were that there can be no areas of increased stress, and there can be no excess weld bead above the pipe's surface and no alignment issues. After experiencing leakage of a recirculation sliding valve packing box believed to be caused by packing damage from the use of a higher pressured nitrogen air purge stream to fix a stuck valve stem, the refiner took the corrective action of using rectangular plates to cover the area where leakage was occurring. The lessons learned were that the use of a higher gas pressure to remove catalyst fines that are causing the valve to stick is only a short-term solution, and that sealant injection should be used if the purge gas flow rate or pressure deviate from design values. The refiner believed metallic expansion joint leakage was caused by component damage during operation leading to the overheating and cracking of the bellows. The refiner took corrective actions by using a patch plate as a temporary solution, then installing additional metallic bellows to avoid a shutdown before the next scheduled turnaround. The lessons learned from this are that pressure and temperature need to be monitored and that internal components need to be examined when the unit is brought offline. The refiner attributed leakage of the carbon monoxide boiler tube to corrosion from dripping urea. The corrective action for this was adjusting the spray nozzle so that injected urea was projected 35 mm out from the spray tip. The lessons learned from this were that tubes need to be checked for susceptibility to corrosion by the liquid used and that nozzles need to be checked for dripping occurring when they are sprayed.